horizontal asymptote. All right, x-intercept. How do you find x-intercept? Zeros of the numerator. So what? So x would be 0. So the x-intercept is a point, so I need to write it as an ordered pair. X is 0, y is 0. So this graph's going to cross right there. Vertical asymptote. How do you find the vertical asymptote? Zeros of the denominator. So x squared minus 4 equals 0. X squared equals 4. So x equals plus or minus 2. Good. So it's going to look like that. So I'm going to have 3 different kinds of looking graphs, one in each spot. Horizontal asymptote. We looked at the degree of the polynomial, and this time they're the same. So when they're the same, it says do the leading coefficient divided by the leading coefficient. So this one's going to be y equals, and the leading coefficient of the numerator is 3. The leading coefficient of the denominator is 1. So y equals 3 over 1, or just y equals 3. So my horizontal asymptote is up here this time. Now, to save a little time, you could make a chart on your calculator, and what's going to end up happening is your graph is going to look something like this. Okay? Did I do something wrong? No, we're good? Okay. Trying to decide about this. Yeah, since that was x squared and that's x squared, the rule is if they're the same, you do the leading coefficient divided by the leading coefficient. So 3 divided by 1. Okay? So this is what your graph would look like, and I wanted to just sketch it up there so we could talk about domain and range, because this one's going to be a little different. The domain, the farthest left value, my smallest value would be negative infinity to negative 2. Whoops. And then start back up at negative 2 and go to positive 2. And then positive 2 to infinity. The range looks a little different because we have a spot in there that doesn't have anything. So what's the smallest y value we could get? Negative infinity. And then it goes all the way up to 0. And do we include 0?
Yes.
Yep. And then there's nothing, right? Until we get to 3. Not inclusive to infinity. Questions about that one?